just going x plus 3. We're changing the signs, x minus 2. It's always the denominator in front of the x, and the numerator is the constant. Whoops. Sorry about that. It should be a minus 1. We still have to change the sign. And 3x plus 4. And we're just FOILing the first two and the second two. 6x squared plus 8x minus 3x, so that's plus 5x minus 4. And then we're taking the first term and going through all three terms of the second parenthesis, second term through all three terms, third term through all three terms. So 6x to the fourth plus 5x cubed minus 4x squared. Rewrite that a little neater. 5x cubed minus 4x squared. Then we go through the x. Plus 6x cubed plus 5x squared minus 4x. Then we distribute the negative 6 through. Negative 36x squared, negative 30x plus 24. So when I combine my like terms, 6x to the fourth, 11x cubed, minus 4x squared plus 5x squared minus 36x squared is a minus 35x squared, negative 4x and negative 30x, negative 34x plus 24, and that's my answer. Now these I'm just going to go through, even though I can give you an opportunity to go over them on your own. The conjugate is always one of the answers, always. So when you have a radical, like an irrational number or a complex number, you automatically make the conjugate one of the answers as well. So this is x minus 4, and we change the sign in front of that lead real number, or lead rational number, which is in this case a positive 2. So it's x minus 2 plus root 3, and x minus 2 minus root 3. Essentially, you're going to create a difference, a difference of two squares. So my first step is to move the parentheses. X minus 2 plus root 3, x minus 2 minus root 3. And what you do is you create a difference of two squares. X minus 2 times x minus 2 is x minus 2 squared. What works out nicely here is negative root 3 times x minus 2 plus root 3 times x minus 2 just cancels. And you're left with positive root 3 minus root times negative root 3. When you have the same number under a radical, the radical disappears. Now that x minus 2 squared, I cannot stress this enough. You've got to FOIL it out. It's x squared minus 4x plus 4. You've got to FOIL this out. You don't just distribute the exponent. So x minus 4 times x squared minus 4x plus 4 minus 3, and I combine those like terms. And then we distribute x cubed minus 4x squared plus x minus 4x squared plus 16x minus 4. And we combine the like terms. X cubed minus 8x squared plus 17x minus 4 is our answer. X plus 1, and then I change the sign in front of this negative 3. It becomes x plus 3 plus 2i, x plus 3 minus 2i. I'm going to leave the sign in front of the 2i's the same. Plus here, minus here. We're moving the parentheses now. X plus 3 squared plus 2i. X plus 3, not x plus 3 squared. X plus 3 plus 2i times x plus 3 minus 2i. Now, same thing as when I did with a irrational number. When I multiply these two together, it's a difference of two squares. It's x plus 3 squared. I get negative 2i times x plus 3 and positive 2i times x plus 3. Those middle terms always cancel. And then 2i times negative 2i is negative 4i squared. Now, the x plus 3 has to be FOILed out. X plus 3 squared is x plus 3 times x plus 3. And that's x squared plus 6x plus 9. So x plus 3 squared is x squared plus 6x plus 9. Negative 4 times negative 1 is a positive 4. So it becomes x plus 1 times x squared plus 6x plus 13. And now I'm just distributing. X cubed plus 6x squared plus 13x plus x squared plus 6x plus 13. And we combine our like terms. 7x squared, or x cubed plus 7x squared plus 19x plus 13. And that is our answer. Alright, so when we take a look at this function, I'm going to do f of negative x, and I'm going to plug that in. Negative x to the 6th minus 5 times negative x to the 5th minus 3 times negative x to the 4th plus 2 times negative x cubed plus 7 times negative x squared minus 4 times negative x minus 1. First thing I'm going to do, get that negative x in there. That's going to account for our negative real zeros. And now I'm counting sign changes. If there's no sign in front of the first term, I'm going to put a plus sign down. That's a sign change. Yes. That's not a sign change. No. Sign change. Yes. No. Yes. No. So there's 3 sign changes, which means positive zeros, real zeros I should say, we have a possibility of 3 or 1. You always count it down by 2 until you get to 0 or 1. Now with the negative, it's always this. When the exponent is even, the sign in front of the coefficient stays the same. Negative x to the 6th power is a positive. A positive times 2 is just 2. But a negative x to the 5th is a negative. A negative times a negative is a positive. When the exponent is odd, we switch the sign in front of the coefficient. When the exponent is even, we keep that sign. So the exponent here is even, I'm keeping the sign. The exponent here is odd, I'm switching the sign. The exponent here is even, I'm keeping the sign. The exponent here is odd, I'm switching the sign. And that's how we accurately plug our negative x in. I'm going to put a plus in front of my 2x to the 6 because there's no sign there. No. Yes. No. Yes. No. Yes. So my negative real zeros is also 3 and 1. We have 3 sign changes, so it could be 3 or 1. So, whoops. So now as I come down to my chart, my answer for total zeros has to be 6 every time. It's an x to the 6th power, so that means there's 6 answers. I can have 3 positive zeros, 3 negative zeros, and therefore 0 imaginary. I can have 3 positives with 1 negative, and that means there's 2 extra imaginary. I can have 1 positive with 3 negative, an extra 2 imaginary, or I can have 1 and 1, and then there has to be 4 imaginary. Going across, I always have to add up to 6, so that's how you get your imaginary numbers. Whatever you need to get to 6. And that's the Cartesian. I'd like you to try it on. Alright, so once again, we're going to put our negative x as a function. 2 negative x to the 5th minus 4 negative x to the 4th plus 2 to the negative x to the 3rd minus 8 times negative x squared plus 3 times negative x plus 1. Now I'm looking to count sign changes. I'm going to put the plus sign here. Yes. 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 positive real zeros, we have the option 4, 2, or 0. Here, we change the sign when it's an odd exponent. Negative 2x to the fifth, we keep the sign when it's an even exponent. Minus 4x to the fourth, minus 2x cubed, minus 8x squared, minus 3x plus 1. No. 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 Yes. So it's negative real zeros. And there's one sign change. So this now becomes 4, 1, 0, 5. Or we can go with 2, 1, 0. Oh, not 0, sorry. 2, 1, 2, 5. Or we can have 0, 1, 4, 5. Once again, each row has to add up to 5. Is this polynomial is of degree 5, which means there's going to be 5 answers.